our back. I've got a few more staples to pull out at various locations. Then we're going to vacuum everything out of here. I've already picked up all the screws. The rest of these are all loose. There's one right there. There's another one in the corner. Alright, shop vac time. Made this little DC power strip, some leftover stuff in the shop. The thing is, I need something shorter than these. That's way too long. Let's see what I've got in these stainless machine screw boxes. Since there's so many things branching off the power supply, I figured I'd go ahead and make it easy for me. Where do we want to put that? I think I'll put it over there. Hang on. That'll work right there. I got 2 threaded holes here with a couple of stainless screws. Attach positive and negative. And you can jump off. Put the power pack down, probably set the power pack down in here somewhere. And I'll need I'm going to wire up a receptacle in this corner. There's a hole back here for the old cord to come through. So I'm just going to wire the cord up to a receptacle. I'll have one for the plug for the 12-volt adapter. And I'll have a junction point there for the 120 volt for the bulbs. And I still don't like this. I mean, this is 18 gauge. This is probably okay as it is. This is 20 gauge, a little small for a light bulb. So I'm gonna put everything back in here. I'm gonna hook it up. I'm gonna hook up my digital multimeter to one of the bulbs. We'll run it, and well, this only on for a couple of seconds. So you know what? We'll leave it as it is. While I'm doing testing, I'll check the wire temp, see if anything's getting warm. If it's not, it's fine. What I wouldn't want to happen is if that thing hangs up and it leaves a bulb on, you know, is this going to get hot powering one of those light bulbs? And I believe the replacement party bulbs, which are right here, yep, they're all 25 watt. I don't even think you can get these anymore. So we'll test it and see. I'm going to go ahead and put everything back together, and I'll wire up AC. I'll wire up the power pack outside using the power strip over here. And we'll see what happens. Be right back. The main part back in. Let's hook up, see, stripe is positive. We'll verify before I do anything. Actually, let me crimp some ring terminals on this. We'll get that stuff. These are shrink insulation. I'm not going to shrink them for this. It's not worth it. Don't do this too hard. It's aluminum soft threads. Where is my screwdriver? Snug it up. That's all you need. It's low voltage. So. All right. Let's hook up power pack. And we'll check the voltage. Make sure we got 12 volts. Positive, negative. Negative, positive, 12 volts. We switch them, get negative. So that's correct. Alright, now we got this assembly here. It's part of the state logic, start and stop. Seems like the original holes are right there. Be in the way of the light. I missed one. Whoops. Right in the way. Actually, I missed two. There's another one right there. Alright, let's run these screws a little bit further in. Try to hang it. Go. Okay, these two are the 120 volt trigger wires, positive and negative. We can tuck those out of the way for now. And these positive. That's AC and AC. These go to the lights, so it controls lights. And we have this goes to a relay up there. This goes up here. And then we have this one, 12 volts, which doesn't reach. And then we have two grounds that need to go over here. One of these will reach, the other one won't. So I am going to splice these, and I'm going to run one ground from here to there, and then I'll splice the grounds for here together and run it to there. Splices over here. I need to go get some. Alright, I'm back with the AC on because it is so humid in here. I can't stand it. Some zip ties. Get this tidy. One ground. Power. This is the only power circuit. It comes from here, and then we have these two here. So I think I'm going to print those separately for Angel. this one, I need to make a jumper. I normally use red for DC, but I'm out. I used it all on my golf cart. That's pretty cool. Let's see if I can zoom you in. You can see it, can you? If I can hold it there. It's melt and seal. It shrinks around, and there's glue in it that melts to seal up the wire and the splice, and it eases out. You see it right there. Okay, so is this the last one? I think that might be the last ground. Now we have our switches here all tangled up. And that one has a nick in it. I might need to rewire that one. Oh, here's a ground. That is for the coin-op switch. Coin-op switch needs a ground. And the palm switch, I believe, goes to, let's see. So it goes to the bottom left, the second, right there. Why did I take that off? Huh. That didn't make any sense. I don't know why I took that off. I didn't need to. So there's the palm switch. Palm switch up there. And this needs to go. Ground terminal as well. Let's just check it and make sure everything is got power like it's supposed to before I crank that one. And I'm gonna pull all the grounds together on that side. Oh, I have a ground here. Let's see. How does that work? All right, there's one. Palm switch. We don't have power over here. Partially activated. Partially installed. Mostly broken. Alright, what did I miss? What did I miss? What did I miss? What did I miss? That should go to ground. That powers that. Oh, I didn't hook the freaking motor. Let's see which terminal that goes back on. This goes, of course it does, because I'm using that as a motor trigger. And yes, I am going to go back and clean these up, strip them properly. I may even put spade terminals on these instead of using the bare wire. Because of that reason right there, there's just too much wire. What are the odds of this working now? Alright, here's our coin op switch. Put a quarter in, triggered it. Now let's hit the palm button. Palm button, nope. Gotta put another quarter in. Quarter in, palm switch. Okay, fundamentals. Bueno. Alright, so let's try hooking up 120 volts to the lights. Put some bulbs up in there and see if we don't have cool illumination. We'll be right back when we get all that set up. Alright, let's give it a trial. So since there's not a relay on the AC power going to the bulbs, the randomizer block is always contacting one bulb. When it stops, it's on the bulb that won or that was selected last. So when I plug it in, that particular bulb is going to come on immediately. That'll be fixed with the delay off relay that I have coming. So once the motor stops, that relay will be triggered to turn off. It'll wait a second and a half, or whatever we choose to set it at. That bulb will stay lit, and then it'll disconnect the AC power for us. And then once you trigger the motor again, it'll activate, it'll cut the AC power on. When it stops running, it'll wait for the same amount of time again, and then turn off, etc. So let's plug it in. It looks like the second bulb got selected last, so let's put a coin in. There we go. And set the palm switch. I see a dead bulb. That blue one right there is out. Got a light blue. Purple. Purple. Light blue. Pink. Pick a pink up here and see. The wiring. Filament's broken through the bulb. But just make sure. Run it again and see the flickers. Alright. Coin switch. Activated. Palm switch. Yeah. They're all blinking. Whoa. Bottom one. Do it again. Credit switch. Palm switch. So cool. Again. Bottom two and that pink one seem to be the most popular. Yeah. have to add a start delay on this motor, on the selector motor, so that there's an additional amount of basically you're salting the algorithm, you're adding an additional factor in that throws off the synchronization of the two motor speeds. With the three set times running with that many options, 2, 4, 6, 2, 4, 6, 8, 10. It'd be better if it was odd, but that should make it a little more random than what it is now. It's still picking the same 3 volts more often than any of the other ones. I still have not seen the yellow in the middle light up. First time I've seen the purple light up. Which bulb? Blue. I think it's going another bulb. Yep, the red. Now the red is going. That red out there is about to go out. Yep. Maybe that switch is going out. Here's the palm plate that holds the switch. That also has bulbs in it for illumination. I bought some new bulbs. They're the same 12 volt. They're actually instrumentation panel lamps, which is what's in here. But there's nothing holding these. They're basically holding by their leads, which is not good. So I printed up these little holders to separate the lead using the existing holes in the plate. These will be glued down to the plywood so that you can have some support on the bulb without it wobbling around, and still be able to clip the leads, pull the bulb out, and put a new one in if you need to. Right now everything is held in series. Everything is held in with hot glue and soldered in series. So if one of these bulbs blow, they all stop working, or if one of the leads break. So I'm going to rewire this in parallel with the new holders, which on my messy bench here is my 3D printer. That'll be starting up shortly. Looks like the bed's at 40 Celsius and the nozzle temp, I have to run it hot. I'm running it at 240 just because it's like 65 typically in my house. So that's where I did the first test print. Blue painter's tape, printing PLA filament from Hondak. It should reset any minute. The nozzle's probably dripping. Once it drops down below 240, it goes up above it and then drops down, and it'll start. This is what I used on the Genesis Coupe project to print the sway bar adapters on, to print the prototypes to test fitment. I printed more than 10 iterations of the model before I finally got a left and a right that actually had enough slot clearance for the bolts to be able to fit most of the variations in subframe, movement and positions and all that. I may set this up and record the whole print job. It's only 2 hours because these are only these are 10 millimeter diameter with a 5 millimeter countersunk hole and a half millimeter, actually 1 millimeter lead hole, 2 millimeter spacing between the leads. But I'm having to print 6 of them. I've got 1 done. I need 6 more. So the first thing it's going to do is lay out a brim, and the brim gives it a little sticky base for the starting bottom part of the model, so that it's not gooey or dirty. It's actually a clean line. When you pull it all up, you just peel that brim off and it just separates from the model nicely. Then you can trim it with a razor or whatever you need to, but you can see it's laying out an overlapping brim here because of the spacing on the G-code file when I laid it out in the printer software. This particular printer is the Monoprice Select Pro. It has the controller in the base. The other model, the Monoprice V2, I think the regular model, has a separate controller box that sits on the side. 70 millimeter max print speed, 100 millimeter travel per second, and 0.06 millimeter resolution. And that's a 0.4 millimeter nozzle that it's printing with. Alright, so I'm going to set this up and maybe we'll do a time lapse of the whole print job. I'm going to set everything up now.